Yo, yo, yo. Let's get this terrain adventure starting. And good morning, Cypher. So, yesterday, let's put it this way. So, I think we really started this terrain business last week and have pivoted twice. So first we implemented a very naive approach, relying on mesh filter, mono behavior, no instancing. Got a pretty good result, got it working at least. Then we pivoted to a terrain-based indirect using a This is not the one I want. Terrain instance. We pivoted to this one with a graphics render mesh instanced call, and then we eventually pivoted to terrain base indirect, which relies on a graphics render mesh indirect call. And it's been a lot of fighting back and forth this week, and yesterday was the problem of getting correct lighting and shadows going. And after, I don't know how, maybe one and a half hour of trying to get this to work, we finally managed to do it. Everything was correct in the shader. The only thing that was needed was to set this render parameter shadow casting mode to shadow casting mode on. But it's not entirely done, because although we get terrain to cast shadows like this, we still have some weird artifacts like this, which boggles my mind actually. And so that's one issue. We'll see how we do with that one today. And this issue right here. So enabling shadow casting for terrain basically halved our FPS, which I find extremely weird. But what do I know? So it's almost like the vertex shader here runs twice. But I'm pretty sure that shouldn't be happening. So, what I'm gonna start with today is that I'm gonna pivot once again. Not forward nor to the side. We're gonna pivot back a tiny bit. So, I want to re-implement terrain-based instanced and terrain patch instanced, and I want to implement this in we're going to rely heavily on instancing, but it's more going to be like a naive terrain implementation with utilizing mesh renderer components and instanced based materials. And I just want to get this up and running because I want to produce exactly the same visuals as this one, including lighting and shadow casting, and I want to see what kind of performance we get with that approach, if we still have the same artifacts and if we still have this extremely bad performance. So that's what we're going to start with today. Hopefully no big problems. Tersiane, thank you so much for the follow, appreciate it. So we're gonna jump to what did we have? Terrain base instanced and terrain patch instanced. And the idea is to okay, beautiful. Pretty much gonna do this. Let's see here. I'm gonna skip this shit. Terrain patch instance data as well. We're gonna have neighbors and we're gonna have a constructor, of course. We're gonna leave this as a class and we're actually gonna make this one mono behavior. So wonder if I want to do... how do we want to do this? Yeah, we're gonna do it like this. Let's skip this. So we're gonna have a private mesh filter, and we're gonna have a private mesh renderer, but we're not gonna instantiate these just yet. And we're gonna add some functions. We're gonna have neighbor references. I don't know if it's that important though, but we'll see. And we're gonna have public void set mesh. So we're gonna create one mesh, and then we're gonna render multiple mesh filter objects with the same mesh. We're also gonna have one material. I don't know how it's actually done practically, but we're gonna have one material with instanced properties. So here, if mesh filter, then we do mesh filter is equal to game object dot get component mesh filter. If we still don't have a mesh filter, then we do add component. Good morning, Geralt. Like this, and yeah, and then we do mesh. Now we're pretty sure that we have one, so we just do mesh is equal to good morning, Harukanon. Like this. We're gonna do something very similar for the materials. We're gonna do public void set material. Although I think we're gonna do, yeah. There's a few properties I want to set here as well, instance properties, and those are do I want to do it like this? Yeah, maybe. Matrix 4x4, translate, rotate, scale. And we also want to set, so in terrain based indirect we relied on something called SV instance ID to calculate patch index and such. Yeah, here instead we're just gonna have terrain patch instanced. Actually, we might have let's do it here for now. Vector 2 patch index. What's up, Toffai? Good morning, good morning. Set material and properties. So here we want to do it's morning here. Same here actually. Enable instancing. This one we will already have set manually. So let's skip that one. Okay, let's get instance ID. Beautiful. Unity material set instance property from script. Material property block. Yes, I am. But oops. Material prop. Do we have something here? No, we don't. Toffai, I'm from France. Oh, nice. Nice. I'm from Sweden. So to the north and east of France, I think. Okay, so here's the first problem today. Material property block. This is what we rely on for the indirect method. Which is instanced as well. Here we create it, and here we set material properties. Yeah, but I want something similar. I want one material. Yeah, surface shader. So texture st unit define instanced prop. Is that how we do it? Is that how we do it if we want to utilize mesh renderers and block? Ooh, get property block. Beautiful. Set property block. Ooh, beautiful. Beautiful. Okay, so what we want to do is maybe we should create the shader as well, so we know what properties we want to be instanced and so on. But okay, great. So I thought it would be... I thought you would be able to set property block per material, but it's per render you do it. There's probably a reason why. But let's see. So currently we have terrain shader indirect HLSL, terrain shader instanced, multi-compile instancing. Oh, beautiful. We already have a few things here. Terrain shader instance. Yeah, let's continue with this one. We do have main text in properties. Do we need properties? Maybe. Multi-compile instancing. And then we have this Unity Vertex input instance ID. So right now we don't have any properties that are instanced, but we have this support and we have this. Okay, beautiful. Let's take this one, terrain shader instanced, and add some functionality to it. And I want to do it from this one. So let's copy this property block first of all. Albedo color, ambient multiplier, smoothness, and specular highlight color. We only need those tags here. Multi-compile instancing. Oh yeah, this is also something we want to do. Path here. Yeah, we want to add a HLSL include, HLSL and HLSL. Actually, let's just copy this one. I don't think... all of these properties are going to be the same per instance, so we can just keep them like this. Then we calculate that like this, and then we add a second pass as well. We're gonna add some functionality to the vertex shader as well. I don't think we need this one. So this, very important, definitely want to keep this. We're going to calculate these things a little bit differently. So we're pretty much going to calculate them exactly like this. So what do we have here? Approximate normal connected neighbors. Beautiful. Vertex shader. I let's see here. Position OS, color UV, position. We're not gonna have normal or tangent. We're gonna have UV. Maybe gonna have color, we don't know. Position clip space, position world space, and we're just gonna have all of these, but without color, I think. Okay, so it's very similar to the indirect one, but we have some instancing magic. So now we want to specify these instanced properties. So we're going to specify them like this, but we're going to have some flags or something, macros or whatever, on the shader. So something like Unity define instanced prop. Oh, first of all, we need to have Pragma multi-compile instancing. Unity instancing buffer, actually. GPU instancing. Let's take a look at this one. Creating shaders that support GPU instancing sounds exactly what I want. The fuck? I don't believe this. Yeah, this is probably what we need to do. Unity per material instanced. Now we do this. Okay. Okay, beautiful. Let's start. Let's just try with this. Let's run with it. So we want to have buffer name. I wonder if we want to put it here, and then we do end as well. What to name it? Okay, so yeah, type float for then, I guess, and we're gonna name it patch index. And then we also want a max height is the same, terrain data texture is the same, delta UV is the same. Fuck, is it only this one that is? Object to world as well. So we have a float 4x4. Float 4x4. Actually, yeah, float 4x4. We're gonna call this one object to world. And oops. Is it only these two? I think it is. So since we define it like this, we don't need to do it. We don't need to fetch it like this. So SV instance ID, we just use them like this instead. And this, and this. But we do need this one. But buffer name and property name. So I wonder if we want to do, can we do, so we do this, and then we do float for patch index is equal to per instance properties, property name, patch index. And then we have patch index here. And then we want to do something similar for object to world as well, but I wonder, let's put that one here. Object to world. Very interested in what this might result in. Okay, and then we have a few properties that we need to set that are the same for all instances, and that is delta world space, delta UV space, and max height. Let's just put them here. So what is it? Float for delta world space, float for delta UV and float max height. A little bit interested about this. Do we have... So down here, I don't think we need per instance based stuff. I'm not sure. Or maybe. We do need this one. We already added that one. Great. We're still gonna do this. I don't know if we're actually using it, but whatever. And I also want to do it in here. Yeah, and this is what we want to do. Okay, beautiful. Okay, great. Then I think we can also... Do we have any errors here? Undeclared identifier terrain data texture. Yeah, that's true. We have a few other properties we need to set as well. Do we have this one as a material? Instanced material. Here we... Yeah, we do. Okay. So yeah, that's true. Terrain data texture. We need to set this one as well. And we're just gonna set it exactly like we do in the indirect HLSL shaders. We're gonna do it like this. I think. Do we want to do it like this? Question mark. I don't know. We'll see. We need patch length UV as well. So let's see here. Terrain shader instanced. I'm gonna have this one here. Note. Maybe use HLL specific. Actually. Question mark. Texture 2D macro. What did we call this one? Patch length UV, and we do have these as float 2. Yeah. Float 2, float 2. Okay. 108. Okay, good. So now we have... Yeah. Now we have the instance material working. That's great. Terrain base, terrain patch instanced. So I think we can do this now. Set material and properties. No, we just set material, and we want to do... Or... Yeah, I wonder if I can do something like this. Let's see here. Private material property block. So we do if, first of all, we want to do a similar check as this one, but mesh renderer. Now we do mesh renderer dot material is equal material. And I also want to do if material property block. Oh, we can't do a check like that. If it's null, new material property block. And then we do mesh render dot material mesh render dot set material property block. Material property block. Okay, beautiful. Then I want to do, so this is where we set the property block to the material, and then we can add functions like public void set position. Although a little perplexed by this. So you can pretty much reuse the material property block. Yeah, I'm not gonna do that right now. I'm also a little bit worried about, let's see here. I forget, let's do set position. Position. And here we do if set matrix Yeah, we're just gonna hard code it for now. Set matrix object to world matrix 4x4 dot trs position okay. Set patch index as well, and I think we put this as a float 2. I wonder if we can do vector 2. Vuchesk, thank you so much for the follow. Set vector, is it patch index? I'm pretty sure this is everything. We might need to set some additional settings for these, like shadow casting, but we'll see. Terrain patch instanced, terrain base instanced. Update. Yeah, let's do it in awake. Index. Oh, fuck. Actually, I think I want to do this. Yeah, I think I do. Terrain patch instance, terrain base indirect. Let's just copy this one. Terrain base instanced. Okay. Dimension, vertex, resolution, texture, resolution, subdivision, constant, height, range, material, terrain data, textures, yeah, terrain data, test variables. Yeah, might want to skip this one. Terrain patches. Mesh. To be honest, I don't think we need to save this one. Command buffer. We don't need these. We do need these. Index height. Do we use these? We use index but not height. We're not gonna do this. We're not gonna do this. We're not gonna do this. Regenerate. Let's keep it, whatever. Okay, generate. First we calculate subdivision, patch length. We do all of those. Then we create terrain patches. Instanced. Yeah, we're gonna fix this one as well, but let's see. We create this one and then we apply it. Yeah, here's, I think we're gonna do it like this in here, so we have a clear here as well, but let's do private mesh create mesh. I don't know if we need to send in a few things here, but return mesh. Yeah, dimension subdivided. Might as well. Is it a vector? Vector. Okay, so in generate, first we create a lot of things here, then we create the terrain patches, but before we create the terrain patches, we want to create a mesh, because we're going to use that one. So when we have calculated patch length, dimension, vertex, texture, terrain, data, delta UV, delta world space, then we also do, maybe we do it here, mesh is equal to create mesh. I'm wondering, yeah. And then we want to create the terrain patches, but we need to do this a little bit differently because we're working with mono behaviors now. So we're going to go to terrain patch and we're going to create it like this basically. Public fuck it, let's create terrain patch instance. Let's add a static function here that returns a terrain patch instance. To create new position, dimension resolution parent, position parent, material, yeah, let's, should we just send in everything here? I think so, except for set neighbor. So we're gonna do create new, we're gonna do mesh, material, parent position, and finally patch index, or just index, you know. And then we do terrain patch object, terrain patch instanced object is static true, name position to string, set parent. Then we do terrain patch instanced, I like to be explicit, but we don't call instantiate here, we call set mesh. Oh, actually, yeah, this one we want to rename set material. So we do set mesh, set material, set position, and finally, almost. Maybe set index would be a better name, but whatever. Okay. So in terrain base instance here, when we create the terrain patch indirect here, we do terrain One sec. Did I remove something here? Or terrain? Fuck. Terrain base indirect. Oh yeah, we don't set neighbors anymore, so I think we can skip that one. Do we need neighbors? No, I don't think so. Nah, we solve it by this instead. So we have the terrain, or like the terrain base star. So the terrain base in each implementation will handle the neighboring, while the patches, the only thing the patches will know are that they are patches, but not the relations. So set neighbor, no. Remove neighbors. Very clean. Okay, so terrain base instanced. Here we want to do terrain patch instanced. Did I create new? Mesh material transform position and index. IJ. Yeah, so new vector 2 IJ. Very interested in this one. Clear generate is going to take some time, but maybe not too much. We should be able to do this. Let's see, is everything material? Yeah, we're gonna have to create this material, make it instanceable, etc, etc. Let's see. What a fucking mess this is. Okay, so we have garden instanced and garden indirect. So basically I want garden indirect, I want garden instance and garden indirect to have the exact same setup. So what is it? 2000 times 2000, 256, 256, 22, 0, 100, 100. Material, terrain default instanced material. Terrain shader instanced, beautiful. Enable GPU instancing. Terrain data textures. So here we want 3, and we want to start with that one. Okay, so it's this one, this one, this one. Yes. Okay. So both of these should be result in the same visuals unless we get any errors. I think we're gonna get some errors. I just want to double check. So we disable this one and this one and rely on indirect. I just want to see the draw calls and whatever we have. Yeah, let's let it default to this one. So what do we have? Batches. Oh yeah, here. Okay, so let me just take a note of this. Temp notes, what do we have? Around, fuck, it's bad FPS. Makes me worry. 95 FPS. And also, whoa, CPU main, 10 milliseconds. Why are we spending so much time on the CPU? Whatever. CPU. I'm gonna take a note of that. I don't think that's quite big. Render thread is around 1.5. Let's see here. Batches 80. Saved by batching 0. And then we have this weird stat. It's weird if you ask me. So triangles and vertices, the terrain we're drawing, are actually not counted towards these stats because it feels weird to say, but they pretty much don't exist on the CPU side of things. One could... that's not the correct way to put it, I would say. I don't really know what the fuck is going on. So we actually create the mesh here. We have a mesh object, but we don't assign it to any mesh filter or mesh renderer or anything like that. We just call graphics render mesh indirect instantly. Or like we bypass all of that and just do this call. And for some reason, it doesn't get included in this if we do that. But, okay. Still gonna write that up. And set pass and shadowcaster. Let's write those down as well. Okay. So now let's see what our instanced one can produce, and I'm gonna do it like this. We're gonna enable it, and then we're gonna do regenerate and hope for the best. It's a bit small, but I think it's okay. A little bit worried about what we're seeing here because I've forgotten to set a few things. So if we go to terrain shader instanced, we actually have all of these properties that we don't set. Although I'm fucking worried why we're not seeing any offset here. It's weird. So, terrain base instanced. When we generate it here, we create the mesh here, and then I want to do a few things with the material in question. So we want to do set Yeah, let's do it down here. I wonder if we can do it here. Material dot set. What do we want to start with? Let's do it in this order. Set vector. Delta world space. It's height range dot max. Oh, I forgot material set vector patch length UV. And finally material set texture. Although I wonder, terrain data texture, terrain data. If we want to do apply first, I don't think it shouldn't really matter, but maybe it's just a little bit cleaner to do it like this. Am I okay with this order of things? So create a lot of reference variables, create the mesh, create the data. So let's regenerate this one again. Let's see if we get some. Fuck yeah. What the hell is going on here? Incredibly rough FPS. A lot of vertices as well. 40 million. Let's see. $2,000. It should only be 250,000. That is true. Shadowcaster's 176. CPU main is spending a lot of time. Yeah, something is wrong here. Definitely. It's like... Okay, first of all, the material doesn't seem to be applied correctly. Terrain default instance material. Is that so? Okay, let's start by doing that. So we want to disable this one. I'm extremely worried about what I'm seeing here. Okay, let's just maybe we need to set shared mesh instead. So Unity mesh, set same mesh on multiple mesh filter. Yeah. What the fuck? Okay. Okay, so first of all, let's exit this and let's change set mesh here. We want to do shared mesh. I don't know if also very interested in why we're not getting any. We have the meshes here, but why we're not getting anything rendered, and why they are occupying the same space as well. We do set material property block. So do I need to call this one again after this? Maybe I do. Then we probably want to clean that up. But yeah, it's almost like we don't set it. Ooh, now we're talking. And okay. So now we have the exact same result we previously had, but we now use mesh render and mesh filter. Let's see what the performance is here then. This is exactly the same. We receive shadow, we cast shadow, and we have the same pretty much exactly the same FPS. Good to know. Although more shadow casters, double 2.3 3 times the number of Shadowcasters. I have no idea why. Saved by batching 75, batches 80, saved by batching 75. Vertices 20 million seems extremely high still. So we actually have 2000 times 2000 vertices per mesh. That is 4 million vertices. But we subdivide it down to 500 times 500, and that is 250,000. The fuck are all these vertices coming from? Okay, the bounds are fucked as well. Is this actually 2000 times 2000 times 16, 64,000? I don't know, this vertex count doesn't make any sense. But we do still have the same shadow issue we have with the other solution. Interesting. I think that's a bounce issue. I hope it is. Definitely hope it is. This performance, however, I'm not impressed. 20 million vertices. From where? So it's basically 1 million vertices per patch. We have, what is it, 16 patches. But 4 million. Am I not calculating something correctly here? Let's see, vertex resolution. Terrain base instanced. Vertex resolution subdivided. Vertex resolution divided by subdivision, and subdivision is subdivision constant 2 to the power of subdivision constant. This one is 2, so we have 4. It's vertex resolution divided by 4 in both directions. And then we use this one when we create the mesh. We create vertices here. We have vertex resolution subdivided plus 1 time vertex resolution subdivided plus 1. So why the fuck? By my calculation, that leads to 2000 divided by 4 times itself, or actually, okay, 501 times 501. So a mesh should be 251k vertices times 16. Yeah, that doesn't become so. Vertices. Then we set vertices to vertices. We only call create mesh once, and we do it in generate. At awake we just call generate. We don't have anything previously. What the fuck? And like not only that, but 20 million vertices. Yeah, I don't know how statistics here displays it, but we should have. Yeah, if they count each as their own, yeah, then I guess we'll get a high value like this. But yeah, still. Number of vertices do not add up. Triangles, 6 times vertex resolution subdivided. So 501 times 501 times 6, 1.5 million times 16, 24. I don't know. $100 FPS. Okay, this is crazy. Let's disable that one. Let's go to garden. What do we have here? 2000. Yeah, let's go with a resolution of 2000. Subdivision constant of 2, 0, 100. Terrain data, we just use 1 here. Static Shadowcaster. Yeah, let's take a look at that one as well. But let's do garden, regenerate. Okay, Sarah, good morning, good morning. I wish you a great job. Are you still working on grass now? First of all, thank you, appreciate it. And same to you. And no, for the past week and a half, we have been battling with custom terrain. Maybe I should have disabled garden instance as well. One thing is for sure though, like this is so much slower. Oh, fuck. So much slower. Okay, so this garden solution here is non-instanced, and we also have, we actually have terrain collision here. I think we don't on the other ones, I think. But we don't have Oh yeah, we don't cast any shadows. So here we have, okay, yeah, let's create that real quick. Actually, let's do garden, world normal, let's do prototype materials, 1 sec as well, instance material, yeah, okay. Jesus, yeah, like this solution, Jesus, is it slow. Let's do regenerate it once more. Great, we now have a proper material with fog and everything. Looks nice. I just want to see what the result is here when we have some proper shadow casting. How is it possible? Okay, 7 million vertices. What do we have? 2000 times 2000. 7 million vertices. Yeah, that's closer to the truth at least. Fuck, this result is actually, do they cast? I don't see. Yeah, they cast shadow, but I don't see. Yeah, we get shadow casting here, and we get such a lot better result. What the fuck? Terrain base instanced here. First of all, we need to check this one, which should have way less vertices. We don't get any shadow artifacts here whatsoever. Okay. Okay, so something with the execution of our experimental approaches is wrong. The question is what? We do get way more vertices with this solution than the other one, even though 2000 times 2000, let's see here. Terrain base. Subdivision constant, dimension, resolution subdivided. And this is the one we use. Create new. Dimension, resolution. Yeah, I don't get it. Okay, so instanced again. $20 million vertices. Okay, the first question I need to answer is why the hell does this solution result in, what was it, 13 million more vertices? What the fuck? Terrain base instanced. I wonder, so the fact is we only create the mesh once. Create mesh, and then we use this one here to create new. Here we call set mesh mesh. Mesh filter shared mesh is equal to mesh. Okay, let's take a look here. find it incredibly odd. Mesh dot vertex count number of vertices. This one should give us the answer. And the answer should be a little bit over 1 million if we want this one to pan out. Yeah, we just printed one time and it's 251,000. So why the fuck is each mesh filter worth 1.2 million? 1.2 million, let's see. Times 16. Yeah, that pans out. What am I doing and where am I doing it for this one? For this, we send this mesh onwards. It's 251,000 vertices, but for some reason it becomes almost 1 million. Terrain patch instance to create new. Is it because we do this 3 times? Nah, but we probably shouldn't do it this many times. So let's see, set material, set position, set patch index. Let's just do let's clean that up first of all. So set properties. Let's see if this affects it in any way. No. Subdivision constant 0. Let's see what we get. So we don't rely on any patching. We're only gonna get one big terrain patch. Okay. Still 20 million vertices though. Subcooler SK? Yes indeed. What am I missing? $20 million vertices. So, terrain base instanced. We create the mesh here. Void generate. We just do generate in awake once. We create the mesh. We log the number of vertices. We get 251k. We don't do anything with this mesh until we create a new terrain patch instance. Create new. Here's the same mesh object. We create a game object, we add terrain patch instanced, we set the mesh. We set shared mesh to be equal to mesh. We set the property block. And we're done. The adventure mode in Dwarf Fortress came out in beta branch. You know what? I really need to check that game out. Have you played it? The adventure mode? Yeah, I don't know what's going on here. A little bit. There's a bunch of things that are disabled because they're not ready. Oh, that's unfortunate. like this looks... Nah, 500 times 500 vertices, that's probably true. I do wonder, however, if the indirect approach we do suffers from the same problem as this one. Which in turn confuses me because I was pretty used to play adventure mode in old version with ASCII graphics. Yeah, it was pretty. Procedural, or actually Unity statistics show more vertices. It's very specific. Okay. What's up, Norindev? Could it be something like this? Norindev, I'm good. How are you? Nice to hear. Same here. A little bit perplexed by the problem we have. Our mesh gets generated with 251k vertices, but when we actually run the scene, it's as if it was generated with 1 million vertices. And I wonder if we have colors. Do we do normal? Recalculate normals. Colors shouldn't affect this, I don't think. It could be that the UVs are fucked, or that the normals are like that we generate it with normals in such a way that we get double vertices in certain places, but I don't think so. $20 million vertices from where? Okay, what happens if we create the mesh and then we call optimize? Is it my material that is so fucked up? Yeah, we're gonna try and render it with the normal material as well. It might be my material that screws it up. That is for show. 20 million vertices, and if we do garden instanced and we do object prototype instanced material instead, what happens then? Still 20 million vertices. Way worse performance. Okay, that's good at least. That's good. But this one. Unity statistics. Vertex count. Verts. Yeah, but this is really doesn't apply to our case because we actually generate it procedurally, but it's like the GPU automatically creates extra vertices in order to handle hard edges, UV splits, and additional light. Yeah, we don't want anything of that. Okay, fuck it. What if we just do no UVs, no normals, no tangents, no optimizations? We just generate a mesh with vertices and triangles. Ooh, do it create? Nah, it should be okay. Is it the order we do this in that is fucked up? Maybe, I don't know. Still 20 million. Let's bring up GIMP and draw the order we do this. I can't imagine the triangle order affecting this. Oops. But if it does, it would be nice to get to the bottom of it. So we do ij plus 1, I plus 1, j plus 1, I plus 1, j. And we do ij, j plus 1. Okay, so we do this, this, and this. And then we start with this one. And we go 1, 2, 3, and then we do 1, 2, 3. Okay, it feels like I'm going insane, but I do want to try this. So let's go with this 1, 2, 3. So 1, I, j, I plus 1, j plus 1, and I plus 1. I don't get it. And I don't get why we spend so much time on the CPU as well. It's weird. It's double the CPU time, and the only difference is that we have 16 new game objects sharing material and sharing mesh. It makes no sense. Thank you. Okay. There we go. Let's see. 500 times 500 is 250,000 times 16. 4 million. Okay. So making them cast shadow, like changing shadow casting mode to on, quadruples the number of vertices and doubles the CPU time for some reason. Huh? Shadow casting, Unity, CPU time. I don't know. What's up, Mercenary Mage? Thank you so much for the raid, and I hope you had a wonderful stream. I find this to be... Thank you, YouTube Mage, and thank you once again for the raid. I find the vertex count... Okay, this is how I see it. Like, we get 4.2 million vertices here. Most of them are batched. Like, it's actually... It's just one mesh rendered 16 times. 4 million vertices. Okay, we get pretty good result if we don't apply Shadowcaster to this. But if we apply a Shadowcaster, we get double the CPU time required per frame, and we drop down to, what is it then, 100 FPS. What bothers me is, okay, we have 4.2 million vertices here. If we do, let's disable this one and add back garden. This one has 2000 times 2000, 4 million. The same. Let's take a look at the stats of this one. So it should be the same number of vertices. We don't have any instancing. And they should cast shadows. Yeah, here we only get 7 million vertices. 2.4 million vertices. Fuck. It becomes weirder and weirder. So 2.2 million vertices. How can that be? We have 16 different meshes with, actually let's see, 500 times 500 times 16. We should be at 4 million. I don't know. Is it, yeah, it's getting cold. Okay. Okay, is that the problem we're having? We're not doing the culling properly. Yeah, that might very well be it. So the performance of... Yeah, that is 100% it. It has to be. It has to be on. Yeah, we got 7.2 million. What if we do... We do camera node, main camera. Let's disable camera controller. Let's bring this one up. Let's bring it back. And then we do still not seeing the result I want. Okay, Shadowcasters, that's probably because okay. Yeah. Okay, so that's the cause of the problem. Great. Love it. So it's a culling problem. So when we render, both when we do instance and when we do instanced indirect, the problem we're seeing is... Okay, so let's enable this one again and let's play it. That's fucking great to know. Beautiful. Yeah, and we still have this one here. Okay, so like if we take a look at all of these instances, they still have their bounds around here. So now to the question, Yeah, I think what we want to do is we want to do, first of all, shadow casting mode. Let's keep it on, and we want to do, when we set position here, we set parent, we set the parent, and then we do transform.set, or actually position is equal to position. Let's see if the bounds get updated accordingly. And we need to do something similar for the indirect as well. Do we have shadow? Yeah, we do. We still have this weird artifact problem, but we have way better performance. We have the same performance as the other terrain, so that's good, I think. Don't like that. Yeah, the bounce doesn't seem to be. Yeah, we don't have any height on the bounce. I wonder if that's a problem with the shadows. Yeah, it probably is, actually. Mesh filter. Is it mesh filter that has no mesh renderer? Mesh renderer. Bounce. There we go. Bounce. Local bounce. The bounding box of the renderer in local space. Feels like this is the one we want to set. Bounce center, bounce extends. Beautiful. What's up, Fabic? Our local bounce. Closing the object in local space. Okay, so if we get the bounds correctly set, both for this one and the indirect method, we should see good performance, I hope. Or like, to be honest, not eye-opening performance gain, like, but we should have at least, we should have the same performance as the baseline, which is CPU based. CPU and mono behavior based terrain. So let's see here. We want to set the bounds here. Do we have everything we need? We have mesh. Let's see. Mesh Unity. This one has bounds. We're gonna take these bounds. But remember, our mesh doesn't have any height pre-shader, pre-being shadered. So that's the only thing we need to fix, and we don't have that information here. So what we need to send in as well is parent position index. And I think we're going to do it as vector2, no, range, height, range. And then we want to do set mesh. Yeah, let's do mesh renderer, renderer dot bounds is equal to new bounds. center and size. Actually, we want to set local bounds, I think. So center should just be vector 3.0. Size should be new vector 3. And here we want to do mesh renderer. Actually, did mesh filter mesh has bounds? Mesh filter bounds? No. Mesh filter, mesh bounds. Yeah, I know. Appreciate it. What we need to do though, I'm just gonna merge these two methods because I don't want to do null checks in both of them. So set mesh and material. Set mesh and material. Because we could do mesh filter dot mesh bounds, but at this point we don't know if mesh filter exists. So mesh material. So mesh filter, shared mesh, and then we just do these two as well. And here now we should be able to use this mesh. So mesh.bounds.size.x. For Y we want to do, I don't know if we have, let's go to range and double check. Random Ragathian mesh already has the bound, so don't need to create a new instance. Are you talking about like creating a new bounds here? This one, is that what you're talking about? Yeah, we do need to do it because mesh, that's just a plain mesh. And then when we jump to, when we render it, we do vertex offsets, and we want the bounds to include those vertex offsets. And that's why we need to specify our own bounds, because this mesh don't know anything about those, right? So mesh here, just a simple plane. We're gonna offset it based on a height map in the shader, but we also need to adjust the bounds for that height offset. So range, I want to add a public float diff. Is that a correct? And here I want to do max min. Is that a good name? Yeah, maybe it is. Delta, yeah, thank you. That's way better. Thank you, I think. Yeah, I think we're gonna use that. Appreciate it. Uniform. Random based on X. Yeah, fuck the uniform setting right now. We're just gonna return new vector3 x.delta, y.delta, and z.delta. Okay, but the most important thing is this one. So x, and this is where we're going to use it. We're going to use it as... we need to send it here as well. Mesh material height range. Maybe not the prettiest, but height range dot delta. Yeah. Delta for me implies step, though. I don't know. Yeah, it's the step between max and min, that's true. Mesh bounds.size.z. So the bound size in the x and z direction, those we have from the mesh. It's this one we need to fix. And that should be it, hopefully. And in mesh or in terrain base instance, we need to send in height range here as well. And that should be it. Okay. Hopefully, best case scenario, we won't have any shadow artifacts either. If we don't, we're gonna add this bound recalculation to the indirect method as well. Fuck, we do have these issues still. We properly... Yeah, we have the correct culling now, I think. But this shadow artifact is still here. I want to double check one thing. Actually, do we? If we take a look at these bounds, can we get... Am I gonna have to draw them? Unity, scene view, show, mesh renderer, bounds. Ah, come on. No, this is not what I want. I don't know. I don't know if we're getting the correct bounce. I don't think we are. Use a gizmo to render them, yeah. That's probably what we're gonna need to do. Private void on gizmo render. What is it? On gizmos render? On draw gizmos, there we go. On draw gizmos, and we do dot draw cube, center and size. Beautiful. We're just gonna do mesh renderer dot. We don't even. Actually, it's not here we want to do it. It's in patch instanced. Draw cube mesh renderer dot bounce dot center. Or can we actually just do it like this? No. So let's do center mesh renderer bounce dot size. Okay. Okay, so what I'm hoping for now is that they actually don't render correctly, or don't get changed correctly, because that would explain the shadow artifacts we're seeing. But we'll see, we'll see. Yeah, we need to enable gizmos. Why do I always seem to forget? Yeah, okay, so it's not entirely... Fuck, we want to draw this as a wire cube, not cube. Draw a wire cube. Yeah, we rendered our gizmos as pure boxes, made it pretty hard to see. Making it as wire cube should make it crystal clear, I think. I hope. Yeah, beautiful. Okay, we can see here that it's wrong. We do have a very weird offset. So center. Yeah, okay, that's true. We might want to offset center point by height delta as well. Okay, beautiful. I like this. So what we actually want to do is when we set it as 0 here, we actually want to set it as height range dot delta, actually 0.5 f times height range delta times vector 3 dot up. So we just offset our center by half the height range delta. And can we manage to have this on one line? That would be nice. Yes. Okay. I would be incredibly happy if this also solved the shadow issue we were having. So I hope we didn't get the correct shadows because we didn't get the correct culling when we did shadow map creation. But who knows? Fuck, we still have this issue. That's very weird if you ask me. But the bounds look to be alright. This though. Oops. Interesting. Clipping plane. Okay, I suppose it's very weird. Frame debug enable. What do we have? This is likely a shadow map settings issue. I hope you're right. We will take a look at it. Main light shadows. This one, right? It's a clipping problem here, right? So this is pretty much the same shape we're getting here, or is it? No, not really. So yeah, I find it very weird though. These splits. What bothers me, so let's take a look at, so this is our custom solution. Garden instance. If we disable this one and we enable this one. So this is, We don't have the same problem with shadows here, I don't think. Even though maybe it's hard to see. What if we do... Okay, so what is it? We have... okay, it's one of these. Like, are we getting this problem? With the other solution as well. I find it... Let's see. Garden instanced, garden. And like with this solution, we don't get the same shadow problem. We don't have the same artifacts here. So in this solution we have mesh filter, mesh renderer. We use object prototype material, so it might be something wrong with our shadow caster. Let's see, cast shadows on. These are static. I don't know if... I don't know. But we don't get the same shadow issue here. Screwing up the depth buffer might also screw. Yeah. Clipping plane 0.2. Yeah, I wonder. So first of all, we have two issues basically. We have this sphere issue here, so we don't have any shadows in a sphere around the camera. And then we have this issue here. Is it both is a receive issue, so it might not be. Actually, our character should be in shadow as well, so is he though? No, he's not. So it's a shadow caster issue as well. Actually, util lighting. Float 3. Do we actually need float 4 here. But this is... yeah, let's... I don't know, let's double check this one. I don't know. $30. Yeah, util lighting. So position CS. Do this actually. Maybe this one just takes a. Let's see here. It should be float 4. Let's see. Might have been a old error that still hung around, I hope. Fuck. I don't know. But I want to get to the bottom of this today, but before I continue, I need to go and grab or make a new cup of tea. So, be right back. 3-4 minutes. Okay, back. Sorry about that. So, what about this? We do have the same, yeah. So what would happen if we took... Whoa, 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 whoa. Okay, if we take this one and we apply... I don't know what happens if we do object prototype material. Okay, that's true. We don't get any offset. Okay, but if we then take this one and do... Do we get any shadow? Yeah, I don't know where to begin with this one. So we have the same problem in indirect solution and instant solution. Something that both of those share is the Shadowcaster implementation. Oh yeah. The two shaders are pretty much identical here. Unity matrix. This should be okay. Although I am a little bit interested in what would happen if we did. Let's see here. If we did. If we did this one, so we do float 4 position world space is equal to so hopefully, or what I anticipate will happen is all of these meshes should I don't know exactly how it will handle the object to world matrix. Previously we handled it as an instanced property. I don't know how exactly how this one does it, but we'll see. So the difference here being that we let Unity's getVertexPosition inputs function calculate the world space and clip space position of our vertices instead. So let's see what happens. We still have this HLSL. Oh yeah, of course. So 130. So the problem is this one, I think. Terrain shader instance cannot implicitly convert from float 3 to float 4 at line 99. Good morning, 7Y. I 99. Cannot convert from float 3 to is it this one that is float 3 then? That's pretty weird. Do we need to do... Or is it this one? From float 3 to float 4. Oh, okay, it's this one probably. So let's do... Beautiful. Okay, let's see what kind of result we get now. Interesting. Yeah, we don't want to do input.positionOS, we want to do positionOS. Okay. Pretty much no difference, but the issue remains. What the fuck? I don't get it. I don't get it at all. Yeah, that's not what I care about. Strange shadow artifact. Hmm. I have no idea why we're getting this artifact, and we're only getting it for our shader. There's a spherical issue underneath here as well. Very weird. We could fix it a tiny bit with these. Doesn't make much sense. Okay. I find this shadow problem very weird. Now, with these settings it works, but you know... What's the reason for this shadow being left? Okay, this one is actually a custom object. Or not custom object, but Unity with a Unity lit material. Yeah. That shadow works, but not this one. What's up? Try something, dev. Ooh, we have an artifact over here as well. The fuck? Yeah, shadow seems to be fucked currently. Let's see here. Shadow artifact custom shadow caster. Try something, dev. Thank you so much for the follow as well. Appreciate it. Yeah, this, we read this yesterday. It's not the same. Issue. Shadow artifact custom shadowcaster Unity. Okay. Shadowcaster Unity HLSL. This once again. HLSL program. Let's see. Okay. Yeah, we don't want to do it with this. One sec, let's see if I can find... Maybe. What do we do? Main light, shadows cascade. Let's see if we can find the answer here. Not entirely sure. Do we have shadow caster? Thank you. Is this what we want to do? Shadow pass vertex, shadow pass fragment. Okay, so to be honest, this... I'm still a little bit perplexed by this. So we get, for most shaders, we get correct result by just doing the shader pass as we do. Would love to see what this one actually implements. Let's see. Shadow Cast Pass HLSL, GitHub. Yeah, here we have Shadow Pass Fragment. Just returns 0. What the fuck? Calculate position in clip space. Return output. Get shadow position H clip though. Which does, let's see. This is also render pipeline lightweight. It's a little bit old. Shadow bias. Yeah, okay, so here's the thing. Which could probably explain a little bit worried about this one as well though. But okay, so what I think is happening is when we calculate our shadow, we use the same clip space position as we use when we render our actual object. That doesn't seem, in most cases that yields a good result, but in this case when we work with extremely big objects like the terrain is, it gives, we get these artifacts, and I wonder if it's related to calculations including this. And this. I want to try, although lightweight. Okay, let's do Unity lighting.hlsl GitHub. Come on. Beautiful. And then we go shader library, and do we have shadow caster, anything shadow deprecate shadows HLSL, maybe. Shadow caster pass. Beautiful. Get additional light shadow parameters. Actually, additional light shadow caster pass. Okay, so I wonder if we need to do packages, core, shader library, shadow. Do we common shadow? And then we have a folder called shadow as well. Let's take a look at both of these. Shadow sampling tent. Hmm. Do we have anything concerning shadow here? Yeah, we do have those two. Calculate shadow mask. Hmm. Shadows deprecated. Very interested in what we have in there. Shadows. We already checked shadows, right? Core, I want to check shadows. Shadows HLSL. Did we check this one? Transform world to shadow chord. No, don't think we want to use this one. Okay, URP, Unity URP proper Shadowcaster pass HLSL. Okay, well, it bothers me. So, like, default is at... When we calculate this one right here, we just do... object to world. So we bring it from object space to world space. Then we multiply it with view projection matrix. We bring it from world space to view space and projection, what is it, clip space. And it's this one, the clip space position, we also use to draw to the shadow map. And like, it seems to work in most cases, not in this specific one. So we want to do additional things. So we want to do some additional calculations when we calculate the clip space position. And you usually do that by defining a, or you would do that by defining a additional vertex shader here, where you do some different calculations with shadow bias and stuff like that. It bothers me, however, because then we're gonna have to do like all of these height offsets and normal calculations and stuff like that again, I think. So the question if you can take clip space and do something differently here, but I don't know exactly how it's used, so it's hard to Okay, so this is how Shady Graph generates the Shadowcaster. What do we have? Okay. The information about this is fragmental and caster pass calculates shadow for light mode. Shadowcaster include, oh yeah, we've been here before. Mileage Shadowcaster pass. Just the normal position, clip space. Okay. Get Shadowcaster position, clip space. Okay, I like this. What do we do? Light direction. Apply shadow bias. Okay, I would love to try this, but what sucks about this is... Okay, so we need light direction. It's this one, apply shadow bias. Fuck it, let's try it. So let's just do it. Okay, so vertex shader input, vertex shader output, we're gonna keep them the same for both of them. We need this one as well. We need this. We need this. Okay, and then we'll take this one. So in our color pass, we do we have a vertex shader and then we have a fragment shader, and I think we want to, I guess we want to should get an error now, I hope. Okay, anyway, the idea is that vertex shader input and vertex shader output, both of these are shared between, or the different passes uses the same structs. We're gonna use these as well. We're gonna use these. And we're gonna use this function in both. So, okay. Wonder if I want to do so in our Shadowcaster pass we want to do position OS. When we get to this, when we calculate the position CS here, we want to do it differently. We want to do fuck it. So light direction, world space, light direction, position CS, transform world to age clip, apply shadow bias, position world space. We don't have normal world space at this point, so let's put that one there. Normal and light direction, okay. If unit reversed, we do this. Otherwise we do this. And not return, but yeah. Something like this. So the only difference between the passes, the Shadowcaster pass and the Universal Forward pass, is here we calculate the clip space just like this. Here we do a few more things, mostly related to shadow bias. Hopefully this works. Fuck. Light direction. Okay, beautiful. Normal world space. Okay, we just do it like that. Let's do output normal world space then. Okay, no errors. That's good. Let's see if we get a better result with this Shadowcaster pass instead. I think we do. Although I would have hoped for better performance, but whatever. Let's see. It's not too bad. It's not too bad. I screwed up these settings quite a bit though, so I don't know. Ooh, okay. Beautiful, actually. Okay, this is very nice. This is actually quite incredible. Although not a big fan of this, but I don't know. This is beautiful. Yeah, we're using guarding ins. Beautiful. Great, everything works. But then again, performance. What sucks though is... Okay, we can probably simplify this quite a bit. And I want to implement this in the indirect as well. and let's add this as a reference as well. Thank you, Fabric. It's very interesting, all of this. And I learned something new here. So, like, doing this in the fragment shader of the Shadowcaster pass with the default calculated clip space position works in most cases. That's how we do it in the cell shade lit. That's how we do it in the procedural grass shader. But I'm wondering if this has to do with the actual scale of things now when we work with terrain or this test terrain. It's extremely big. We're talking, what is it? 2000 times 2000 meters, so shadow bias and stuff like that might affect it more. I don't know, but apply shadow bias. Extremely. I do want to know what this exactly does. Indeed, Fabric, indeed. I agree 100%. Okay, this is great. Jesus. I don't have that much time today. More time today, unfortunately. But let's check this one. Apply shadow bias. I'm pretty sure it's in lighting. So let's go to Core HLSL, lighting, apply shadow bias, apply shadow bias, Unity, unit skill plus 10 indeed, shadows HLSL, is it in here? Here we go. Inverse n.l, so normal dot product light direction. Okay, and then we scale it based on shadow bias. Why? Okay, so we offset the position with we offset the position in world space by shadow bias X in all directions multiplied by light direction. Okay, so we offset it in the light direction by shadow bias X. That's the position world space. And then we also offset it in the normal direction times inverse n.l times shadow bias Y. I have no idea what's going on or why. Would love some write-up or something. I'm gonna add it as a note here. Like, I do want to know what's going on here. Research shadow bias. Hmm. But let's see here. The shadows are amazing right now. They're extremely good. I love it. Like look at the very good. Okay, one step closer at least. So, okay, so this is terrain shader instanced. I would like to be, let's see if we can simplify this one a lot. So I wonder as well if can we use different structs per pass? HLSL different structs per shader pass. Or actually, let's do Unity HLSL shader pass. Because when it comes down to it, if we take a look at the shadow caster vertex here, we do need object to world, we need patch index, and we need to read the height value. Actually, the most important part is if we take a look at vertex shader output here, the only thing we need in the Shadowcaster pass is this one. So, like in the vertex shader pass, we need all of these to properly calculate the lighting, but in the Shadowcaster pass, we just need this one. So if we define these per pass, we can skin this a lot, and I think that's good. So I want to try that. Worksband, thank you so much for the follow, appreciate it. But that is going to be the task for tomorrow. So, because, let's see here. Just want to write this down here so I remember. Skin Shadowcaster pass in terrain shader instanced. Apply or continue implementing terrain shader. What the fuck is it called? Indirect. Yeah, I know, Fabic, I know. So I think, unfortunately, I don't have the time today. Look at all of this. Jesus. But we made some good progress. So tomorrow, hopefully, I'm gonna do these two. We're gonna skin the Shadowcaster in the terrain shader instanced, and then we're gonna continue. We're gonna take the knowledge we learned today and we're gonna add it to terrain shader indirect, and then we can compare the performance of those two. I don't know if there even will be one, but then this one should be done, and yeah, then I wonder if we want to do this and then eventually this. So I'm very curious about this terrain collision just using the height texture. It should be incredibly fast, right? We're pretty much just gonna test. We're gonna transform a world position to a texture. We're gonna transform a world position to UV. So per entity, we will transfer a world position to a UV coordinate. Then we will read a height value and we will compare the height value to the entity Y position. That should be it. And based on what we get there, we want to apply velocity in some direction or force in some direction. I don't know. That would be the most straightforward way to do it, I think. Then if you want to... If you want to include more like proper physics, I think we're going to have to step it up. But we'll see. We'll see. Great progress as usual. Thank you so much, Fabic. I appreciate all the support. So yes, we'll continue this tomorrow. Unfortunately, I gotta run now. But as always, everybody, thank you so much for watching and have a great rest of the day. Peace.